Hello guys, this is a direct online motor control panel. Direct online motor control panel is one of the most basic control you can have for your electric motor. So we have just finished doing the connection. Some of my participants that came for training actually did this under my instruction. So we did it together. I gave them some assistance from online. So I want to explain what everything is doing. So we just finished the connection. We made a little mistake, but we've been able to correct the mistake in the control side, and the LED is now able to come on correctly. So we used three LEDs, 1, 2, 3. I will show you the LED on the drawing. So this is the drawing. In this drawing, we have two sides, the power circuit by the left and the control circuit by the right. So my LED symbol according to IEC is this 1, 2, and 3. So this LED starts for green and this LED is stop for red, while this LED is yellow for false. So that's what I just did in the circuit. I used two LEDs, red, this red, yellow and green. So when we look at the control circuit, we see that where I drew my control line from L1, it goes straight through the overload auxiliary contacts. Then from here it branches to the red LED. So I expect my red LED to come on immediately based on what I have from the control. Once I energize it, the red should come on. Then secondly, whenever there is a fault, there is a mechanical link on the overload. It's going to switch from normally closed to normally open, and the yellow LED should come on immediately, which is H3. Okay, if there is no fault, my red, which is stop or ready, will come on. Now this is my stop push button and this is my start push button. Once I press the start, the power comes through this line and energize the contactor coil. Once the contactor coil is energized, its auxiliary contact KM1 comes on, changes from normally open to normally closed, and acts as a latch. So once I remove my hand from the push button, which is a spring return push button, comes open and the circuit goes on. As the contactor is energized, it ons the power circuit here and supplies power to the motor, so the motor starts. Okay, now once the motor starts, the auxiliary contact here, which is 8384, will close. As this coil energizes, the auxiliary contact closes and it powers the start LED or the start indicator. It powers it on and tells me that my motor is running or it has started. And at the same time, as this and this are closing, this normally close would immediately open and the red LED will go off. So that's just how the control circuit works. It's a very simple circuit. You can actually try it on your own. It's a very simple circuit. Okay, so let's now look at what we have in the power circuit. So in my power circuit, this is my cord. This is my three-phase power coming from this cord here. Okay, so this is my three-phase supply. Now my control is coming from this side. That's the entrance to the circuit breaker. This is a 4-pole circuit breaker for live 1, live 2, live 3, and neutral. So I deliberately put my control here so that while my breaker now is off, I could control or test my control circuit without energizing the motor, because the motor has also been connected through the overload. This is the overload output to the motor. So my motor has been connected. So it enables me to be able to test my control circuit without disturbing the power circuit or without energizing the motor. And that I can easily clear out faults. So on the power side, you can see that there are just 3 wires coming out from the circuit breaker, and they go straight into the contactor main winding. The contactor means contact, that's the input of the contactor. So this part is to be controlled, contactor control. And this is the output from the contactor. This is the contactor, this is the overload. Then top here is the auxiliary contact. So this auxiliary contact, they are mechanically linked to the main contact, such that once this guy is energized, this thing plunges down. It plunges down. Once it's energized, it plunges down. That's the main contactor attracts it and draws it down once it is energized. So that's what we're having in this circuit. So this is the electric motor. My motor is start connected. It's not connected yet, so I can touch as I wish. But when this thing is running, please ensure you don't bring your hands here, because you can get electrocuted. So this thing is actually star connected. This star connected. If it's delta, my bar will not go like this. It will go straight in this way. So this star connection. This is the motor. This is the shaft, and this is the fan that cools it while it is running. Okay, so I will simply energize this, and we'll see how this circuit behaves relative to what we have on the drawing. So let me clear the area around it. So this is my cord. I'll simply place this cord now and energize this motor here from these 3-phase contacts. Okay, so while I did that, you see that now my red LED has come on automatically. I should have a form of breaker. I should have a form of breaker from this positive side going to the control. Maybe a 1-pole breaker or a fuse can be connected in between. But this is just a test circuit, and it's a trainer board. It's not a main board. This is for training. But if I'm going to be doing this for a client, this is actually the same exact wiring. There's no difference. Okay, so if you are going to be doing it for your client, just improvise and put a fuse in between this wire going to the control. That means you are supposed to have a kind of fuse. You're supposed to have a fuse here. Should have a fuse here, just a fuse rated so that it's protect either a fuse or a breaker should be there. Okay, so let's continue with our test. Now, since my circuit breaker is on, I can test this. If I power my circuit breaker on, once I press this start, the motor starts. I can see that this motor is not actually doesn't have anything holding it, so I don't want to do that. I will disconnect my power circuits and test it from the control now. So once I press the green, I expect this red LED to go off. Can I switch the light off so that okay? I expect the red LED to go off and the green LED, this green LED will come on. So let's do that. You can see that red goes off, green comes on. Then I can also simulate fault as I did earlier on. Okay, I can use this to simulate the faults, and the yellow LED comes on. So yellow comes on momentarily. Yellow comes on. When I remove it, yellow goes off and it goes back to the normal states. So why is this yellow coming on? Because this is like a switch, like I'm simulating faults. So where does that happen? It happens from here, from this circuit. By pressing that, this normally opens, and this mechanical link is linked to this, and this normally closes at the same time. So the supply would not come here, this place opens and this place closes. So the power comes like this and goes straight and on the yellow LED. Okay, so let me put that back. So this is what we see have in the correct circuit diagram. Okay, so let's go back to our test now. So from here now I could simply put off this. I've started it, my red is on, and when I press red, green goes off, when red comes on. So I'm done with the test. My control side is working. When I'm sure my control circuit is working perfectly, then I can put on my breaker and I'm ready to test the module. So I'm going to power it on now. I think I should just set this like this. Okay. Okay, so I'm going to power it on now. I will hold the motor now and power it on with. I'm going to power it on now. So that has been powered on. You can see the green light is on, and once I press stop, the motor goes off immediately. That's it. So I'll press on again, and you see it go on and go off. Then I press off, then the motor halts to stop. Okay, so thank you very much for watching. Please like and subscribe for more interesting videos.